So welcome to today's class. Remember to download the computer studies app if you would like to have more notes on the topic we are talking about today. So this is our first computer studies topic, and that's computer studies form 1, and the topic is introduction to computers. And so we are going to learn about the parts of a computer, development of computers, classification of computers, and areas where computers are used, definition of computer lab, safety precautions and practices in a computer lab, and finally hands-on skill. So let's get started. So the first topic, we are going to define what a computer is, and in our definition of what a computer is, we are going to encounter three key words which we need to define right now, so that when we get to the definition we are able to understand what a computer is. And so the first word is data. Data is a name given to facts. For example, in our organization revision KE, we might have look at the number of students who are using the computer studies app, the number of tuition teachers, the names of students, and the name of staff in our whole business setup, and that's data for us. And so information is a result of the data that we've processed. For example, when you add 2 to 4, then you get 6. Then the 6 is the information, the 2 and the 4, they're the data. And so the last word we look at is the program, which is a series of instructions written in the language of the computer for them to obey and perform specific tasks as outlined by the instructions. Let's move forward. And after we've understood the 3 keywords, and now we put this together to define a computer as an electronic machine or device that takes in data, which are facts as we defined, in the raw form, processes the data to give out in another form called information. And what's a computer all about? We first look at the processes, and then they'll help us understand what exactly a computer does. So we have the input processes, storage processes, processing, output processes. I'll give you a minute so that you read and internalize what we are trying to understand here. And if you have a question, feel free to just type it in the comment section. We'll for sure reply to that. And so input, the user will type the data from, say, a keyboard, which is a computer part, and then the computer will accept the same and store within it storage. The data that is fed needs to be held somewhere. That is before processing, which is the third process. And processing is the computer will manipulate the data held within it to a more useful form, which is now the results, the information. And this information that has been processed needs to be given out. So it's important to us when it's given out. When it's within the computer, it has no use to us, and that is the output process. And so the parts of a computer, while you hold the thought I've given you, is as you can see, there is a monitor which deals in the output process. There is a CPU which does the processing and the storage. There is a keyboard and a mouse which they give the computer data to process. We'll get to more formal definitions of the same. So the parts of the computer are like this: the system unit, which is part that houses the brain of the computer, called the central processing unit. The keyboard, it's the most common device which allows the user to, or enables the user to, enter data and instructions to the computer by pressing its keys. We have the mouse, which is a device that enables the user to issue instructions to the computer. The monitor, which is simply a screen like your TV, which allows the computer to output the data that it has processed. We then look at some short history of computers. And so before 1900, most data was done manually, like counting stones, sticks, something that you also did in your lower levels of study. And then around the 2000 years, the Asians came up with something called an abacus. And these I leave it for you to go do some study and know, at least know how to represent a number using an abacus. So over time, computers have been developing into more complex machines as we see today. And so this whole history will be summarized in 5 generations. These are just a few, those that are those that are not known to us, the first generation, the second, and the third. We look at them into details, take key interest in the comparisons. So we have the first generation computers from the 1940s to 1958. They were very large in size, used electronic gadgets called vacuum tubes. I'll show you them later. And they used to consume a lot of power, and this resulted them to break down constantly due to the excessive heat. The second generation computers from the 1958 to 1964, I'll call them the 1960s. They used tiny solid state electronic devices called transistors that were much smaller than the vacuum tubes. These computers produced less heat, they were much faster, smaller in size, and more reliable than those with vacuum tubes. The third generation computers from the 1960s to 1970s, the third generation computers, they used some devices called the integrated circuits instead of the transistors. The fourth generation computers, they used more tiny circuits and transistors into even smaller integrated circuits. You'll see they are common known as the LSIs or the VLSIs, the very large scale integrated circuits. And finally, where I believe we are, the fifth generation computers. These are today, they are faster, more complex, and all that. So I hope you took an interest in the trends, which I'll summarize, which will help us wrap up this whole discussion about the history of computers. And so, one, I hope you noticed that they moved from the vacuum tube, the technology used, to transistors, to integrated circuits, and to the very large scale integrated circuits. And so I'll quickly show you what they are. And so this is a vacuum tube, or the Munich valve. They went to transistors, then they quickly moved to integrated circuits, and finally we have the very large scale integrated circuits. Let's clear this so that we explain the other trends that you ought to have taken note of. The processing speed goes on increasing while the physical size of the computer decreases. The heat factor decreases. What I mean by the heat factor is how much heat is being produced. So to our modern day world, we classify computers in any of the following manners: the physical size and processing power, the purpose for which they are built, and their functionality. So quickly, we classify computers into 4 main groups according to their physical size: supercomputers, mainframe computers, mini computers, microcomputers. This is what a supercomputer looks like, and they are used mainly for research. You won't see them around. They are used in very large organizations to conduct research. In military they use them for weapon analysis and so on and so forth. And something that is of interest to us in this current world is the nuclear physics. They are used in such kind of complex researches. The mainframe computers, they handle all kinds of problems. They are well smaller than yes, so they're used in government agencies, big research institutions. This is when you might come across them in banks where they have a lot of data to process. Well, data that is quite huge, but not like what we talked about in the supercomputers. Well, of course, they're slower than the supercomputers. Then we have a image of what a mainframe would look like. A mini computer resembles a mainframe, but it's slightly smaller. It's quite often referred to as a small scale mainframe computer. This one is used in scientific labs. You can see them in institutions of higher learning, which they for research, accounting. Then we have what is closer to us, microcomputers. These are smallest. They're the cheapest. Their processing power is quite sufficient for normal use, like in training, learning institution, businesses, and all that. And so we'll fast forward to classification according to purpose. That is, in this manner, in this respect we have two subgroups, the general and the special purpose computers. And so the general purpose computers, they have been designed to be able to perform a variety of tasks if or when they are loaded with the appropriate programs. For example, your phone, you're able to use to make a call from your phone if you have the application to do that. You're able to play a game from your phone if it has that specific program in the device. Then we have special purpose computers. These ones, they're designed to serve a specific purpose or to accomplish one particular task. So there's an image of your calculator. Your calculator cannot make a call. It's a computer. Since you are able to give it data, it's able to process and give us feedback. This other image, this funny image over here, I know we've seen it somewhere. We must have seen it somewhere. These are fuel pump. It's a computer. How let's try explain how, in what respect is it a computer. You're able to key in the, let's say, the amount of fuel, the amount of money you'd like to spend on fueling. This is for your dads and moms. And then it's able to process that, and the fuel attendant is able to give you fuel that is equated to the money that was keyed in. So I think the value of keyed in that data, it has processed and it's able to display to you what you've signed up for. So let's move forward to classification according to functionality. And so here this is according to the type of data that can be processed. So data exists in two forms as for now. That the two forms that are relevant to us right now, and that is discrete data, commonly known as digital data, and there's the continuous data, which is commonly known as analog data. So computers, they can be classified according to this. There's the digital, there's the analog, and there's the hybrid. So let's look into that in detail. So digital computers process digital data only, and this is in zeros and ones. Any data that For any data to be manipulated by a digital computer, it must be first converted to digital form. Let's look at analog computers. This refers to computers that process data that is analog in nature. This continuous data that is like speed, temperature, pressure. So hybrid computers, they are designed to process both analog and digital. And finally, let's look at the areas where computers are used. So I hope you've seen this before. These are point of sale system. These are computer that you will see it in the supermarkets. That's one way that computers are used. In hospital, these are MRI machine. It's a computer. In hospitals, in transport systems, I think we've all traveled and we see transport agencies, like any bus that you've boarded. You see they're able to track where the bus is. You're able to pay a ticket online. In communication, we have phones. Law enforcement agencies, industries, education, domestic and entertainment, library services. So I'll focus on the education, which is key to us right now. So computers are widely used in the teaching and learning process. Learning and teaching using computers is referred to as computer-aided learning and computer-aided teaching. For example, experiments in subjects like chemistry and physics may be demonstrated using a special program that can depict them on the screen through a process called simulation. Another application of computers in education is exactly what we are doing right now, online learning. Let's now define a computer lab. A computer lab is a room that has been specially prepared to facilitate installation of computers and to provide a safe, conducive environment for teaching and learning of computer studies. When you're setting up a computer lab, you need to think about the following: security of the computers, programs and other resources, reliability of source of power. Remember, we defined a computer as an electronic device, the number of computers to be installed, and the maximum number of users that the lab can accommodate. Safety precautions in a computer lab: avoid exposing computers to dust. This is because dust contains small abrasive particles that can damage computer components and cause wearing of moving parts. Avoid carrying foods to a computer room. Foods may fall into the moving parts of computers and damage them. Liquids may spill over. Remember, the computers are electronic, so may get shocked. Avoid unnecessary movement because you may accidentally knock down peripheral devices. I think we did not define what they are, but these are the likes of mouse, keyboard. Those are peripheral devices. At all times, follow the correct procedure of starting and shutting down the computer. This is to avoid loss of data and damage to computer programs. These that I'm presenting right now, you'll need to remember them when you are sitting for your various exams. That is cable insulation. All power cables in the computer room must be properly insulated and laid away from busy pathways in the room. This to avoid accidents. Stable power supply. Computers are delicate devices that require a stable source of power. Burglar proofing to prevent unauthorized access to the computer room. Ventilation. There must be good air circulation in the computer room to avoid suffocation and overheating. Lighting. The computer room should be well lit to prevent eye strain. If eventually leading to headaches, stress, and fatigue. This is the last bit of our topic today, that is hands-on skill. You should find a way, you should get to know at the end of this topic how to do basic stuff on a computer, that is just to put it on and put it off. That's our lesson today. See you in the next class.